Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about addition of vectors. So how do you add vectors together? All right. Before I proceed, don't forget to like, share, and subscribe. If you've not clicked notification bell, I don't know what you're waiting for. Please click on it so that when I post new videos, you'll be the first person to know. All right, so how do you find how you add two vectors together? So in order to find the sum of two vectors, let's say we have vector A and B, all right? So what we do is that you have to draw them as a chain. So like what I talked about in the previous video where we have you have something like a taxi, you're going from your house to the shopping mall and you're going to either take a taxi. So the same thing. So you're going to start from a particular point, you draw it as a chain, and you keep on adding to where you want to end. Is that okay? So it's very important that you take note of this. And also it's very important as well to take note of the direction as well. All right. So I'm going to write this down so that for those that are taking note. So to find the sum of two vectors. So let's assume we want to find the sum of two vectors. Let's say A, okay, and B. Okay. Then what you do, we draw them as a chain. Starting the second one, where the first ends. Okay. Now the sum, which is the resultant. So let's call the sum, let's call it C. Okay. So the sum C is given by a single vector joining the start okay, joining the start of the first to the end of the second. Okay, to the end of the second. So let's assume we have something like this. Let me take this a bit up. So we have a particular vector. Let's say we have vector AB. Okay, and this is called vector A. Okay, and we have vector B. So let's assume it's a vector BC, but it's called vector B. Okay, and you're now told to add these two vectors together. So what I'm saying is that you just take a vector starting from the beginning of A that is going to stop at where you want to. And this is going to be called vector what? C. So therefore, now I can now say vector AB plus vector BC is equal to going to be vector what? AC. Okay? So that means you're going to have A plus B is equal to what? C. All right? So that's what we're saying. So if you're adding two vectors together, so you're going to draw a line from the beginning of the first vector to the end of where you want to go. So just like what I talked about, moving from shopping mall from your house to the shopping mall, it's exactly the same principle here. Okay, good. Now let's pick some examples. This is not so much. Let's pick some examples and solve. So if, for example, we have this now, we have this diagram. So we have something that looks like this. We have something like this, 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 and this. So this is A, B, C, D, and E. Okay. And they are both going in this direction, same direction here. Okay. And we have this will be vector A. This is vector B, vector C, and D. Okay, vector A, B, C, and D. Let's call it this, vector A, B, and C, and D. Okay, now let's pick out some question here. So if, for instance, you are told to now find the following. So number one, you're told to find vector AC. Okay, so vector AC. So you want to move from A to C. So that means we're looking for A to C. So you draw a line from where you want to go to. Are you seeing it? A to C. So you want to move from A all the way to C. So it's the same thing as going from A to B and B to C. Are you seeing it? So it's going to be equal to A plus B. Is that making sense? Now, if, for instance, you were told to look for, let's say we're looking for AD. Okay. AD, the same thing. We're looking for AD. Okay. You can say the same thing as saying vector AD is same thing as saying AC plus CD, or you can say AB plus BC plus CD. Okay. So you can say the same thing as saying AC plus CD. Okay. And also we know AC is the same thing as saying what? A plus B, and CD is the same thing as saying C. So you can either say or you can just go A plus B plus C. So any of them is going to give you exactly the same answer. Then let's pick another one. So let's say AE. So looking for AE. So we can go A, B, C, and D, or you can say AD plus DE. So it depends how you want to do it. So you can say it's what? AD plus DE. And we know AD already is what? A plus B plus C. And DE is what? D. And that will be the answer for that. So you can see it's exactly similar to what we've talked about, but it's just taking it just a step further. All right, let me add one more example. So if, for instance, we have this shape here, we have something like this, like this, and like this. So we're told that this is P, this is Q, this is R, this is S, and this is T. Okay, and we have this, that, and that. Okay. So for instance, and you were told to find vector PT. So we want to move from P all the way to what? To T, vector PT. So how do you get there? So in order to get from P to T, you have to first go to PQ. Then you go to what? QR. Then you go to what? RS. Then finally, then you now go to what? ST. And this is how you get the answer for that. All right. So let me pick one more. Let me just pick one more. Then I'll go to the next video, which will talk about the component of a vector. So let's assume we have this, we have something like this. We have this, oh, sorry, this. We have something like that. Uh-oh. So we have something straight like this. Yep. Something like that. Something like this. And we have something like that. And we then have something like this. Okay. So like this, we have, let's say we have AB. Then we now have another vector BC. We have another vector CD, another vector DE, another vector EA. Okay. So for clarity, we'll call this vector A, vector B, vector C, vector D, and vector what? E. So the first one, you're now told that you were told then to find, number one, vector AC. Okay. So vector AC, so you want to move from A all the way to C. Okay. So that means you'll have to move in the same direction. It's going to be AB plus BC. It's going to be AB plus BC, which is then be giving you what? A plus B, okay? Now, but if, for instance, you were told to find CA, now let's assume you were told to find CA, you're going to still add, but you'll be adding CB, are you seeing it? Plus BA. But instead of us to have A plus B, CB, because we're now going in the other direction now, are you seeing it? It's going to be minus B plus BA is going to be what? Other direction plus minus A. So it's going to be minus B minus what? A. Okay? If we're going in the other direction. So you need to be very careful. Remember, vectors talks about both magnitudes and what? And directions, okay? Good. So let's go for another one. Let's assume we're asked to find vector AD. Vector AD. So we're going from vector A all the way to D. So AD now is going to give us, we have to now go to A plus B plus C, because we're going to go to AB, BC, and CD. So it's going to be what? AB plus BC plus CD. And that will give us AB is going to be A plus BC is B plus C. Okay. What about if we're now told to sum all the vectors in the diagram? Sum up all the vectors. All right, so what will happen? So that means it's going to give us, we're moving from AB, we're then adding BC, we're then adding what? CD, we're then adding what? DE, and we're then adding what? EA. Now you can see now in this case that we are back to where we started. And because we are back to where we started, the sum is going to be what? 0. Okay? So because you're summing up all the vector in a closed figure, in a closed vector, because you're coming back to where you started, it's going to be 0. Okay? So So we talked about the vector sums earlier. We've talked about a vector diagram, but if it's a closed figure, so if you're adding all the vectors in a closed figure, and the end of the last vector coincides to where you started, then the resultant sum is a vector with no magnitude. Is that okay? So for instance, if I'm asked to find vector A, okay? So I'm out in a closed figure, I'm told to add up all the vectors here together. So it's the same thing. So if it's a closed figure, no matter how the figure look like, so if it's a figure like this, okay, let's assume we have a figure like this, and we have vector A, B, C, D, and you are told to sum up all the vector in this closed figure, it's going to still give you 0, okay? Now I'm going to write this down so for you to take note of it, that the sum of a vector in a closed figure will always be 0, so that you can put that in your notebook as well. So just to remind us, okay, so remember, the vector sum was given by the single equivalent vector. Okay, so we talked about that it has to be joining the beginning of the first vector to the end of the last. Okay, but there's something I need to keep here. Now, but if it's a closed figure, so if the vector diagram we're talking about okay, if the vector diagram is a closed figure, like the last example, so if the vector diagram is a closed figure, okay, the end of the last vector coincides with the beginning of the first. So that, take this a bit up, so that the resultant sum is a vector with no magnitude. Okay, so with no magnitude means 0, okay? So that means the resultant is 0. So if you have something like this, okay, the addition of those vectors, So when you add the sum of the vectors in a closed figure, the resultant vector is a vector with no magnitude, meaning that it's 0, okay? And that will be that for that. So that's how you add vectors together, all right? So the next video I'm going to talk about is components of vectors. So it's very important that you subscribe. And if for any reason you're confused and you don't understand anything, please drop me an email and I'll get back to you as soon as I can. I'm going to see you in the next video where we talk about the components of vectors. All right, so see you soon.